Hey folks, we're going to get started real quick. I'm Ed Mullen. We'll get into the more formal stuff in a second. Randy's actually the president of CMAP. But I want to take a moment as we run out of networking time to kind of do like speed introductions. So I'm Ed Mullen. I am the reluctant president of Malto MSDN and have been for like 15 years.
And the non-reluctant president or vice president of CMAP.
Yes, yes.
That would you love.
And I have a software development background. I, am amazed that Clippy is back. So that gives you an idea how long I've been in the business. Go ahead.
Sure. My name is Masood Quim. I'm an ETL developer. I've kind of just started my whole career, so I'm just really interested in meeting new people and just kind of getting the whole, cloud architecture and like machine learning, kind of AI kind of aspect of it.
My name is Raghav. I'm a machine learning engineer at Booz Allen. I work at the NIH currently with Kidambi. We've worked together a few times. I'm really interested to learn more about using AI and other parts of that.
Good evening, everyone. I'm Rob Howarth. I am an engineer at Microsoft in the Azure cloud environment.
My name is Mark Floke. I'm retired, but I'm thinking and still doing IT every day. Thank you.
Nice.
Christopher Steen, I've been software development about 30 years or so for Metron Incorporated out in Reston, doing development for UFT contract.
Jim Brooks, been around CMAP since near the beginning of it, and software developer with Northrop Grumman.
My name is Will Brooks. I'm a student, and I didn't get dragged by him here, but I was told there's free pizzas.
Oh,
Woo-woo.
Hey, I'm Joe Mishpat, software developer, currently unemployed, but my last company that I worked for, Scott Allen, was the CEO.
Kendall Miller, career CTO, currently out looking for my next thing, an adventure, and just here to meet folks.
Benjamin Davis, a software developer. I'm at Brown Advisory right now, down in Fells Point. So we do a lot of integration development with like Boomi and then also the .NET.
My name is Chad All. I'm a software developer working at FBI Systems.
Alexis Cherenko, work for Ubiform in Belgrade. I'm C#
Adam Ford. I worked at Mindrug, .NET developer, too many years.
I'm Lawrence Baird, Baird Consulting Group. We're a consulting and recruiting company. So if anybody's looking for a position,
Hi, I'm Joe Craig. I've been around a while. I'm a web and C#.NET developer. I am not retired. And to put it, first of all, it is so nice to go to a place and see fellow professionals face to face. I got to tell you. But part of my career back in the early 80s involved doing a lot of machine learning work with neural networks before neural networks were cool. And I'm talking about data on punch cards.
You guys.
Mike Wilson, .NET developer, been around for a while doing all kind of development and everything like that. Used to come to CMAP back in the day. Haven't been here in a while. Life, kids, and figured I'd kind of stumble back in here and learn a little bit about CMAP's cloud.
My name is Jeff Sanders. I'm a chief architect at Microsoft. I work with Kidambi, and I've been hanging around these three guys for like 2 decades now, and I know many faces here, so happy to be here.
At least with me. I'm Randy Hayes, for those who don't know. I'm president of CMAP. And in my regular life, I am president of a company that does, basically we do technology for small to mid-sized companies, and we help them be efficient with the technology that they already own. So lots of fun stuff there. But with all of that, now the papers that you have, you got to write down every name that you had heard tonight. So make sure you do that. Otherwise, no pizza. But speaking of pizza, we would like to thank Lawrence. He is our sponsor tonight for pizza. So thank you very much.
To eat pizza right now if it wasn't for you guys.
Yes.
Good pizza choice too.
But we are definitely very excited to actually have everybody together again. This is the first live meeting that we've had since before the pandemic. So it's been a long time that we've done this. This is also, tonight is CMAP's 23rd year anniversary. Wow. Some faces I've seen since the very beginning, and we've had a lot of new faces. We've had people come and go, and a lot of technology, a lot of different sessions, a lot of different everything. So it's been very exciting for the past 2 decades, and we're excited to kind of bring it back alive again and get things going. This is a little bit different of a format for those who remember CMAP of the past, where we had all the formalities of all the checking in and all the different registrations and all the other kind of stuff. So we're going to be a little bit more laid back in some of the meetings. We are also taking a more quarterly approach to meetings instead of a monthly meeting. So instead of trying to push everybody out the door every month, we're going to be looking at doing stuff a little bit more on a quarterly basis. And also then dovetailing it with the Balto MSDN schedule so that everybody kind of has a selection of things to go through throughout the quarter. So that will get more information out about that as we go along, but keep that in mind as we make it all happen. And let's see, that's about it that I have to say, but one thing that's very important is that we are actually meeting again, and we're meeting in a place. And that place,
There's a chair back there.
oh, and that place is here at DP Solutions.
Yes.
And so I would like to introduce Joe to speak with everyone a little bit about DP Solutions. We got Joe and Caitlin here, and we're really thanking opening up the doors and letting us come in and use this space.
Thank you, Randy. And I almost definitely am the least technical person here. But we here at DP Solutions, we're an MSP, a managed service provider. So we support local businesses in the DMV with IT issues, kind of bridging the gap between the techies and the end users that just want some help. But so we're happy to have you guys. This is our headquarters here in Columbia, and we like to use our spaces, have some good food, host everyone. So welcome, and looking forward to a good presentation.
Yes, very much appreciated. Thank you. So with that, I will keep one tradition, which is to open it up if anyone has any announcements or any upcoming events or anything of interest in the tech world that other people should know about.
Like job openings or any folks looking for gigs or what have you.
There are 42 different openings on my team at Microsoft right now. So if anyone would like my contact information and find out more about where to apply, then
That's good.
careers.microsoft.com is the best place.
Are they remote jobs or?
Several of them are.
Gotcha.
And that's just my team. So that's a longer conversation.
Oh, speaking of that, we are planning to go over to the local brewery after the meeting,
Yes.
which is almost walking distance from here. I'm not sure we want to walk this time.
Yeah, it's not a wall.
Yeah. And it's Sapwood Brewery.
Great. Yeah. That's perfect.
I just had a question. I know what CMAP is. What would be one of the reasons that I would go to Baltimore MSDN?
Oh, that is a great question. We have divided up the state. Randy stays down here now. And I take Hartford, Baltimore County, and Baltimore City.
The turf war.
Yeah.
But yeah, Baltimore MSDN spun out of CMAP because I didn't want to drive down to Columbia.
But now you are.
But now, like,
Yes. Yeah, it's convenient. If this isn't convenient, then just, we'll start up another chapter wherever you are. See maps all over the place.
yeah, and the other thing, we'll probably be live streaming a lot and using different rooms that have hybrid capabilities. So, don't let geography be an obstacle to seeing a good presentation. And the other thing I learned during the pandemic was, I am so happy you were here in person or whatever, but we had some great presentations from people in other states that like would never have come to, Maryland to do a presentation.
Yes, very true. That's very true.
I think we'll see more of that.
I hope so. Yeah. And speaking of that, Jeff, did we have online folks?
Yeah, we're live streaming now. I can't see how many people are doing, but we're recording it, and I've got links in the meetup as well as Baltimore MSN and the CMAP site, and we'll share a recording on this afterwards.
Awesome. Awesome. Great. All right. Well, with that, I think we're all good on announcements. There were no other ones. I didn't skip over anybody. All right. Okay. I'm going to turn it over to you then, Kidambi. Take it away.
Thank you. Hey all.
Hey.
So this is my first ever, and I tend to speak fast. So please let me know if you want me to slow down, or if you don't understand my jokes that I try to make. Because I'm not good at making jokes. Neither am I good at understanding them. All right. So the agenda today, that's the agenda that you see on the screen here. Introduction, purpose and use case, architecture demo, and discussions. In the discussions, I also like to go about the art of possible of what you can take the solution and go from there. Okay, not just this one, but also kickstart your thinking engines to say, man, that's all there is. No, it's not. It's just a starting point and see how we can transform. And I'm going to provide you some scenarios and have some discussions there, and hopefully you guys also can have a discussion. Right?
Is there any way you could share your screen really quick?
Oh,
Perfect.
All right. Good. So, since you all got to introduce yourself, I'm going to introduce myself. I do FLO, first level robotics coach. I do gardening, woodworking, and I do photography, landscape photography. And in my spare time, I work for Microsoft as a cloud specialist. Right? So that's about me. Who here has seen the movie Office? Yeah. Oh, perfect. So when I joined my previous company, right, the first day, my peer, I introduced myself as Narasimhan Kidambi. It's a pretty long name. And the guy immediately says, Naga Kidambi. Do you know the reference? Naga.
Not going to work here anymore.
Yeah, exactly. Thank you. I was like, man, that's a bad joke. So then I stopped introducing myself as Narasimhan Kidambi. So now I go by Kidambi. So please feel free to call me full name or Kidambi. All right. I've done 25 years of software development, just like you all, and I specialize mostly on Azure, AI, Power Platform, cross-platform solutions across all three to provide a unified application, not just one aspect of it. Try to integrate them so you can leverage all of them. Right? That's the idea. And I'm an app dev. I don't work with security, networking, IP address, being all those numbers. No, I don't touch them. I'm purely app dev, C# and Python, mostly .NET. So that's me. All right. All right. So I've been working with AI since the alpha version of OpenAI, even before Microsoft invested in it. When, I don't know if you remember OpenAI, when they were there small, they opened up the free, it was free at the time, they released the alpha version. So I was in one of the events in Dallas, and I used that to do some kind of a hackathon project to do language detection using Azure OpenAI. So that's when I started working with AI. I've been working with AI, OpenAI, and other models. So while doing that, there are a lot of search you would have seen using AI. Right? It's just so saturated that I'm literally sick and tired of search. I don't want to do search. So I wanted to see something else, and I was trying around looking at other aspects of use cases, and suddenly one of my customers, they reached out and said, okay, we have a use case that we want. That use case is that, before I proceed, I just want to let you know, if you see my customer's name here, or if you see any of the contents, please treat them as deep fakes and ignore. Fair enough. All right. I did try to remove them, but some things do fall through the cracks. So please, thank you. So the customer comes over and says, hey, we have a lot of documentation, a lot of FAQs, README files, markdowns. websites, documents that are written by people all across different fields that they don't follow a particular style. Like if you look at language, right? They have language structure, voice, tone, paragraph structure, narrative structure, punctuation, grammar, all that is all over the place. So they said, we have a style guide, right? Set of rules that includes tone, voice, capitalization, acronyms, paragraph structure, the capitalizations, the commas, semicolons, right? Including 508 compliances for non-visual elements like textual aspects of all text and all stuff. And we want to make sure that all these people who are writing, we don't want to intrude them, but we just want to make sure that the eventual project or the output of the document, they has to run through this rules guide and have to fix it for them. Manually, they are now trying to edit it manually, they're trying to tweak it manually, and then context gets lost. You got to go back, check with each individual, hey, the context maintained or not. So there's a lot of pain in there to maintain an organizational like standard language or the look and feel of the documentation that are used across the different steps. So I said, okay, can AI help us? Right? So being Microsoft, of course, yeah, definitely we can help you. So, so we jumped in. It was really challenging. So I had to take about 2 days of understanding what language is from the word etymological perspective, what a tone meant, what does structure of a paragraph meant, what does difference between semicolon and colon, when you put apostrophe, when you put quotes, how do you use acronyms in a paragraph in structure. So I had to go through that, understand that, work it out with AI, and I'll show you what that is. And then came up with this product where they could submit a document, it'll run through their rules, right? It'll upload their rules, collect the documents, run through it, and spit out a document. Contextually, they will be the same, but it won't be word to word, right? That's the output. It will match all the rules for it. It'll rephrase it based on all the rules. It'll be contextually the same meaning. That's the output they're looking for. And by doing that, you see all those 4 big circles on the screen: standards, automation, configuration, and portable. It's achievable. You can any standards you want, right? You put your rules. You don't have to follow through spec flow or domain-driven language to define your rules or any kind of rule engine or syntax you have to learn. Just write it in. You can put it in CSV, put it in Excel, put it in Notepad, and upload it. Word doc, PDF, doesn't matter. You can pick it up, right? And then automation, right? You can wire it up as part of your check-in. When they have a document management system, they check in, it kicks off a workflow or approval. You can put that in there and have that automated, generated, and submitted for approval, right? Highly configurable. You can change your rules anytime. If you have a version, of course, you can have it changed, upload it, the rules library gets updated, and the next time the person submits it, it gets automatically updated behind the scenes. And since it's written in such a way, you can wire it up with your cloud provider, you can wire it up with your desktop, native applications. You can even, for example, I want to talk this in discussion, but you can also, hey, I want to write this text in my email or a thing, and I want to run it through my organization's style policy, sending out to my customers. How does it look like, right? And then to extend it more, Microsoft 365 Copilot, right? You can use that in your Office documents along with it as a plugin for 365. So those are the extendability of the solution that you use. And that's what the solution is all about, right? So this is the architecture that I did for them. It's 2 parts. The one on the top is a storage where you upload your rules. And on the top, Azure function picks up a blob triggered function. It picks up, reads the rules document, and generates a list of rules for the AI to pull and apply. Right? So the user, you as a user are writing all the rules for the organization, you write it in CSV, you write it in a tissue paper, take a photo, upload it, you put it in a voicemail, whatever the case may be, you upload it, right? Doesn't have to be, it's a highly unstructured document. It picks it up, runs it through AI, and generates a rule library for you based on that. It's a very particular syntax and structure it follows. Using prompt engineering, we built it up. And then, okay, now we got the rules library. That's the automation part. That's a configurable part. You want to change it, you want to change it. Just go there, create a new version, upload it back. It gets approved. The rules library is automatically updated, right? And then the bottom part is where, okay, now that we got the rules, now I got a document. I got a README file. I got a software architecture style guide, right? I got my user guide. I want my markdown formats to be validated against organization policy because I want marketing materials. I want to check it and make it a public repo. I want to make sure that it goes all according to standards. So when they upload it into the second storage at the bottom here, then another function picks up. That function, it loads the rules from the rules library, takes the document that you uploaded. And the document, again, you can upload a markdown, you can upload a Word document, you can upload your own CSV if you want. If you have it written as a spec flow, upload it. And it does, since those documents can be varying in size, like 30 pages, 10 pages, 2 pages, few paragraphs, it splits it apart. It chunks it. Right? And then what it does is, for each chunk, it will run through all the rules. So say for example, you have Kidambi with a lowercase k. That's all you have, is Kidambi. You take that and you have one rule about capitalization and one rule about paragraph structure or the voice. So it takes it, since it cannot be chunked further than one word, that's the chunk you're gonna get, it puts it into rule number 1. Rule number 1 output comes back and says it's capital K. And then that goes into the rule number 2. So the output of the previous rule becomes the input of the next rule. The reason it was done that way is because once you break up the document into chunks, for example, for lack of a better word, you could have paragraphs, right? Each paragraph, you don't want to run the same paragraph in rules in parallel. You don't want that because you could have sentences and they could be violating the tone, they could be against the language structure, acronyms and all this stuff. So you run rule by rule, right? And then the way it parses the rule, it uses prompt flow. And as we go towards our presentation, I'll tell you why we leverage prompt flow. Anybody here use prompt flow? Okay, so we'll go into that a little bit. I won't go deep down because it's a vertical by itself. But we use prompt flow, which in turn calls Azure OpenAI. We use GPT-4 because it's much more better. So we could be dealing with large documents, so we need the chunk size of the token. And so we use prompt flow and Azure OpenAI to generate the results. Okay? So to visualize this, and then we store that in the CosmosDB. And there's a whole structure we store. You get to see each chunks, what was the original text, what's the final text of each chunk, and what was the process it went through. What was the input for rule 1? What was the output of the rule 1? How did that become the input of rule 2? How did that become an output of rule 3? So you'll get the full traceability stored in CosmosDB, right? So if I were to do it, this is how to do it, right? You upload a document, assuming that the rules library is all set in play. Like you got the rules library extracted out, put in. It parses the documents into chunks as I was talking about. So and then it loads the rules. After that, it runs that one block. For each chunk, it runs rule 1, rule 2, rule 3, rule 4, all the way. For my customer, we had 58 rules, right? That takes a while. So imagine you're uploading a page or 40 pages. You're going to chunk it, and each chunk is going to run across 58 rules. It takes a while. But you can optimize that depending upon, and I'll tell you once I get how you can do that. So if you see here, the most important is the chunk 1 goes into rule, output of rule becomes the next input of the next one, and eventually you get what is called a formatted chunk. So you get the original chunk, paragraph, and then you get the formatted paragraph. And that gets stored in the output. So is the next chunk. So is the next chunk, and it keeps going all the way. And here's the thing, bam. All the chunks, you see all those horizontal bars there, they are run in parallel. So if you have a page of 3 paragraphs, that's like a word, 3 paragraphs, 3 chunks, that's 3 parallel executions, right? Each chunk will go through all the rules, but in parallel, and they will come and collect them into that output. If you see the output, it's a sorted output. It's a sorted list that's stored in .NET, right? So that you want the same order in which the chunk is there in the document is also outputted in your outputted format, so that you can collect all the output and you can do a side-by-side comparison. That's why it was sorted out after it's chunked and rules evaluations. And that's the run in parallel, right? The chunking part. How many of you have done search AI with chunking strategies? Awesome. Then you know the pain in chunking. It's not simple, it's not accurate, it's highly subjective. There is no thumb rule, there's no formula to it. So this solution leverages semantic kernel. Anybody knows semantic kernel? Awesome. You can use LangChain if you want, you can use any chunking strategies you want. This is a semantic kernel, which in turn uses semantic chunking, right? And the way it works is it takes a text, right? And there's a token limit for every AI. I'll just give a brief introduction of chunking. Depending upon the underlying AI model, there's a token restriction. You can only have this many tokens to get response. Say, for example, GPT-4, right? Initial response is 4,000 tokens. So the chunking it takes is it takes the text and keeps concatenating. It takes one word, then takes another word, then takes another word, takes another word, till it hits that token. So it takes 2 words, runs a token calculation to see if it is less than or equal to the model's token count. If it is, then keep adding it. And then it'll check to see if it is semantically the right place. You don't want to stop in terms of your ID and forget about AMDI. You want to stop at the word, at the places with comma, punctuations. So that's why the semanticity come along. And also you want to make sure that you're not splitting in the middle of a paragraph where you lose the context. Those are all the aspects of semantic. It's a pretty complex process, a lot of trial and error. But semantic kernel is listed out. You can use language. If you use Python, who's Python developer here? Awesome. So you would have seen retrieval, recursor, all that sentence transformers, all that applies. If you use ML.NET, you can use all those transformations, do also chunking in that. And it uses a lot of NLP techniques to do the chunking, right? It's a pretty exhaustive process. But semantic kernel, I use the semantic kernels, and it's not one line, that's it. And you just tell it what should be the token count, and it'll get into semantic chunking. So once you get the chunks, it will run the rules and it will. The bottom part is the example of what the rules that were given to the system in a completely natural language way. There's no structure to it. Can you guys see it? Or should I? Yeah. That's just basically how the rules are. So you have the acronym rules, it's categorized in acronyms, and then you have the button labels. If you have button or in your UI, that's the label content that you want to apply on labels. And then you have the capitalization. That's how the rules they have, my customer. So that's the step. One rule, the output goes to second, then goes to the third, and then goes to the output. Before I proceed, any questions? Yeah.
Are the chunks normalized in any way? Like if you have HTML versus a Word doc versus Markdown, how much are you losing?
So
in the
before you only hit the chunk, good question. For people who didn't hear or online, the question was, how do you normalize the chunk? What if the input text is in a different format? How do you normalize them to a standard string format before you use the chunk? Did I get that right? Yes. So you see the step where it sparse documents into chunks? That's the step where it takes all of them and converts them into string. So we JSONify or convert them to JSON string. So if you have a markdown, you read the markdown. If you have an Office document, you use OpenXML format. If it's HTML, if it is in .NET, you can use HTML agility pack to read the content. So you remove off the tags. You only get the content. You also get the links, so you can parse it and extract the content using HTTP client. If you use Markdown, if you're Python, you can use the Markdown reader to get it. If it's a PDF, there are many libraries you can use, PDFbig or Aspos. You can read and extract the content out of it. The only thing in this that you will not retain is the layout of the original document, right? Because it was a compromise we made. If you go with the layout, that means now you're talking in some form of a structure, right? You have headings, you have sections, title, or bulleted list table of contents. Some document structures are different. PDF is different. OpenXML is different, right? CSV is open all strings. It's difficult to maintain the structure there. So the compromise was, yeah, we want the capability to do natural language and any format we want as easy as possible. Layout is something which is highly subjective. We can do that later. Right? So that was the compromise made. All right. Yeah, sorry.
I'm sorry, I just looking, you have one of the rules there that says, like your first rule that kind of says, hey, if you have an acronym, the first time you use it, show it this way. The second time, use it some other way.
Yeah.
If you're running everything in parallel, how do you nest?
This
in the third chunk.
The rules are not run in parallel, but chunks are, and semantic chunking. So the same rule will run for every paragraph also. So if you have the same acronym in the first one, same acronym in the second one, right?
It's the first time it's used in the chunking.
Yes,
You have to write the rules out.
Correct.
Okay. Not the first time in the document, first time
Yes.
in the chunking.
yes.
Gotcha.
So there are caveats to this, some things that again requires testing. One thing is that rules can overlap or contradict each other. So I had a rule where at the end of the sentence, my whole paragraph became like one sentence. Because there were a lot of contradictory rules in there regarding the grammar, regarding punctuations, regarding acronyms, regarding the tone, the voice, and all that stuff. So kind of shrunk everything and summarized it into a single line. Like, okay, so that was like, was something wrong with my prompt engineering, something wrong with the models? No, actually, then I had to go through the rules in troubleshooting and found out, and I literally broke out. This was like 15 rules around one shot. I don't know which one, so we looked at the thing because I'll show you how the traceability looks like. So I saw exactly which rule broke it. I took that part, ran it in OpenAI, ran it in Azure OpenAI, multiple models, and then said, yep, the rule is contradicting with the others. So let's rephrase it in such a way. And then we introduced things like you can choose which rules you want to run, depending upon the field of the document it is addressing. Not all documents have to address tone. Not all documents have to address acronyms, right? Some acronyms are globally understood, right? So you don't want to do anything to those. So you can add filters to your rule. You can also order the rules. You can say which rules should come first, which rules should come second. So you can do all that stuff with this. That's the capacity of this. The whole thing relies on, to your point of that, is the chunking part. If your chunking is messed up, yes. So that's why a lot of time went into the chunking. Okay. So we're going to go demo. I know this is live. I'm going to take the risk of running this live.
Nice.
Okay. If it doesn't work, you can blame Jeff. I have it recorded, so we'll go over at least the part of where it's going to process the rules. The demo I'm going to show is I'm going to show every step. What's the document? What is the rule? How it is looking like? And it's going to wait a while. And since prompt flow and Azure OpenAI, throttling, timeout, things might happen depending upon the network, we'll give it a shot. If not, I'll run the demo and we'll walk through it. I always like demo to be live because it's much more fun than something talking. We'll give it a shot. Yeah. So here we go. That's the document. All right. Can you guys see? You want me to zoom in? Is that better?
Yes.
All right. That's the document. There are some few issues with the document. You see capital G, it's a lowercase. United States is lowercase, right? So just for the sake of time here, because this is resource intense, right? Your big documents going to chunk and run through multiple rules. I shrunk it down to one rule, capitalization. So you get the idea of how to run this. And that's the text I'm going to run. And you're going to see how it capitalizes. It'll upload and all that stuff. And then I'm going to show you the right. So these are the rules. Remember the rules library? Originally, somebody will give you a rule in a notepad, voicemail, CSV, Word doc. That got uploaded and it got categorized into these rules. Okay. This is the rule library. And I said in my previous slide where it loads the rules and runs against them, it's going to run against them. And this is the capitalization rule. Okay. So if I look at the content on that, don't worry about the structure here. This is so that's the content that I pasted. Some of it I'm going to move fast because it does have the deep fake stuff in it. So that's basically what the capitalization rule looks like. It's going to load this rule and run it. Okay. And then this is where you're going to see, this is the CosmosDB that we talked about. The output is going to be shown here. Okay. I didn't have time to put a pretty UI. I'm not a UI person. And I don't want to learn HTML, CSS, JavaScript, zillion frameworks just to write a simple page. So I said, okay, let's go. And anyway, this is a technical meetup. So we're just going to go look at the structure and see from there. Okay. And this is the Azure Functions one. And these are the settings it has. And if you see here, I have shown you the rules filter here. See how I set the filtering? I said out of the 58 rules that's been defined, just run the capitalization. All right. And that's my storage account. So if you go here, that's my raw style guide that I extracted out from a URL. My customer gave me a URL where they had the style guide. I read that text file contains the URL. So I read that URL and I created that into the rules. And you saw the rules, right? So now we got the rules. The rules contains the rules library. Input is where we're going to upload that Word document. Okay. And this is the rules in full, if you want to see, without the deep fix. That's the rule we're going to run. Okay. All right. So let me open up. Let me give it a shot and be brave. This guy out. I don't know how to hide this, guys. I'm going to open up the log stream so you can actually see. When I upload the file, you will see the steps like it's going to chunk, it's going to detect how many chunks are there, it's going to run the rule, and it's going to, there is some logging issue I'm having because I was debugging, which I shouldn't have. The demo today, I shouldn't have touched it. But being developers, we know last minute we got to make the change. We know it's there. We got to fix it. But you're going to see two entries in there, but it's not executing twice. It's just that the app insights and host JSON is. Okay, so we got this connected here. Okay, so let's see. Demo guard. I'm going to upload that Word document. Let's go to the log stream. Oh, it's kicked off. There we go. Can you guys all see this? Yeah, so it's chunking the text and it found one rule. So it loaded the rules from the load library based on the filter. It's chunking the text of that document since it's semantic chunking and it's checking against constantly for every word against the token count. It's taking, if it times out, oh, good. So it didn't time out on the chunking. So we got total chunks as one chunk. Okay, now it's running the capitalization. So this is where it's using prompt engineering, prompt flow, and giving it to Azure OpenAI. Azure OpenAI is going to take the rule, the prompt engineering, and I'm going to show you what the prompt looks like so you can see how it interprets this. And then it's going to spit out and say, I'm going to save it to the database. And once it's done, we can see. If this times out, then we will do the demo, the recording, so you can actually see the whole. It does take a while because prompt flow, we are running on my tenant, so it's got the lowest infrastructure, the lowest stuff. Oh, demo guard is on my side today. All right, so it finished, and we got the data outputted and stored in CosmosDB. Right? Again, it found one rule, it chunked the text, it ran the rule, and it saved the output. Got it? Let's go look at the output. That's the output. Can you guys all see? Mm-hmm. Yeah. Better? Yeah. Okay. All right. So the structure of the output is this. It's going to tell me the file. It said how many chunks were found. And you see here, the chunks is an array. And it is sorted, right? So you have the chunk index 1. And that's the final text. So let's see how it looks. We'll open up the Word document. That's what looks. the United States GI Bill, right? Remember, this will not be an exact word to word, but contextually, it should mean the same.
Added in line and everything else in there too.
Yeah. There are some bugs in here, right? Because I haven't run the other acronym rules. Like you see here, this guy should have been capitalized because it being an acronym. But I didn't run the acronym rule, so it just didn't treat that as an acronym. With me so far? Yeah. So that's the output. So imagine you writing all your language and stuff. You don't have to worry about the style guide. You don't have to worry about the standards. Just upload. Bam, it'll do it. Right? So prompt flow. I was going to talk to you about prompt flow. Yes? Prompt flow is a tool that you have in Azure. Who has done prompt engineering in respect to AI? Okay. Before we go to prompt flow, I said I'll show you the prompts, right? Let me show you the prompts. Let me reduce the size. It's too big for me. Sorry. Okay, here we go. I'm gonna do that. Close. Oh, close the. One second. So this is the prompt. It's actually a. Paste it in a way so you guys can see it. You want me to zoom this in? All right, that's the prompt. What I mean by prompt is a prompt is nothing but a set of instructions, behavior, attribute for the AI telling who you are, who you should be, how you should react, and set of instructions on what you should respond with, and some examples telling and the structure of the output and all the stuff. That's what a prompt is. Basically, tell the AI what to do. All right, that's the prompt, along with the rule and along with the chunk. All three given to Azure OpenAI. And you saw the output. And you can customize this however you want. But remember, this structure that you see here is not the structure that you saw in the CosmosDB, because that's an interim structure. That's coming back to the component. All the formatted output I showed in the PowerPoint presentation, that's what that formatted output is. This guy. Okay? Yes.
So the prompt, so instead of like writing code, you're attacking verbally different people.
Correct. So natural language way of telling instructions. So the prompt has got few parts to it. One is the role. What role should the AI play? That will affect how your response is going to be, how it's going to provide the answers. Part two, it has got behavior. How do you want the AI to look at the data and treat it? What is the data it is looking at? What are the parameters of the data? The third thing are the instructions on how it should respond. You want it to respond in a JSON format. You want to respond in a markup format, in an HTML, C#, bullet list, right? And then there are other aspects of it. You can give it what are called examples to train the AI model on the fly. If you don't understand that, here is a simple example. Kidambi is not doing good. K is not capitalized. And the example should be K capitalized, it's not doing good, period. That's an example, the capitalization rule and the grammar rule. So you have that plus the instructions, plus the role, plus the structure, you give it to Azure OpenAI, and it's going to give you back the result. That's what prompt engineering is all about, is how to talk to AI. roles, instructions, few short examples. And you would have heard about natural language to SQL, right? Anybody heard natural language to SQL? Yes. So I did a project for another customer like just like that through prompt engineering. I just said, give me the total sum amount for this category. It generated the SQL and came back the data. Just how you control the AI is through prompt engineering, right? Imagine you doing this prompt engineering with multiple versions, multiple models. This same prompt, you can run it against GPT-4, Llama, Meta, Llama Index, Phi, Orca, all those. And you want to see how they perform. It's a very manual process. It's painstaking. It's difficult to track. That's why prompt flow comes into play. Right? Prompt flow is part of machine learning. And it's part of machine learning where you define your prompts, your input parameters here, and you define what your output is. And you can also call Python code in here. So this can make out API calls. It's called function calling. Have that do the work for you, come back, and that's the structure, and that's the visual representation, how your flow looks like. But that's not it. That's not the cool thing about this. The reason why we chose to do prompt flow, we could have just said, man, this is just API, call AI straight, man. Why are you going through prompt flow? Right? Remember how I said one chunk run against rules? I want to evaluate that parallel across multiple models. I want to evaluate it and the metrics that you get, how accurate is the response? You don't get that from Azure OpenAI or any AI out of the box. Things like groundedness, responsiveness, reliability, right? Relevance. Those metrics you don't get from any AI solutions that you use, but you want to see how good your prompt is so you can fine tune. You want to know which model to use it against. Do you want GPT 3.5, GPT 4, or you want to use Llama, you want to use Phi, right? Which model do you want to use, right? So based on the metrics, that's where prompt flow comes into play. I'm going to stop at this point. You have what is called a built-in evaluation. You can provide your own question and answer pair and check the prompt, and it will run the test, and it will give you the metrics. It's a whole, prompt flow is a whole field by itself. All the data, it's part of machine learning, it's part of AI Studio, and you can definitely leverage it. And you can tie it up with Azure Databricks. It has an endpoint. All it has is an API. You can publish it as an API, and you can call it for any automation. And it's all managed here. You don't have to store your stuff anywhere else. Keep it here. That's the reason we went with prompt, so they can tweak and understand the metrics from the data. Okay. Back to my presentation here. The demo worked good. Yes.
Yeah. Good job.
Thanks. So, credits. He's my app dev chief architect, peer of Jeff Sanders. He and I can't take full credit on this. He worked with me on this. He worked on the prompt flow. I worked on the remaining aspects, along with other data scientists who evaluated the prompts. Thought I should give credit to him. Discussions. From here, all right, now we got a document. It's validated. So well. Right? Think this way. If I can tell a document to rewrite it using the set of instructions, the next step, I fear to say, I can have it rewrite the way I write. Yes? Mm-hmm. So if I have to write an email, I can give it a sample of Kidambi emails, give out Kidambi responses, and I can go to Outlook and say respond. That's it. Right? My email templates, my email responses are the rules. That's how powerful this solution is. Not just validating a document. You can take this and run it to rewrite anything you want in a particular style. There's a project that we did where not only just rewrite it, right? You can also use it for deepfake detection. It's not there. It's the first step. How will you use this? Rules, right? you can provide a set of things for it to identify. Compare it with an actual one and run it through this. Then use prompt flow to compare. Make sense? You know how I said a language has got voice, tone, conversational style, paragraph structure, navigational structure, layout structure, dialogue structure, storytelling pattern. Those are all, there are 12 categories of the language on how a person writes. Generally, a human being. You can take that, define those rules, and you can use that to detect deepfake. Those are the art of possible of this solution. That's why I wanted to share this with you, is not because it could just validate a document. Just like you go to search using AI, you search, you converse. That's not the end of it, right? After you search, you take those results and you have to do something with that results. Imagine if AI can do that results. Right? I can just go to Bing Chat, for example, not that it will do for me, but go to Bing Chat. Hey, I'm having a demo, order a pizza and charge it to my bill. Bam. It's going to go search. It's going to know my history, my preference, figure out that I like this, and it's going to order it because it's got that, and it's going to deliver it for me. I don't want to just say, Bing Chat, what's the closest, what are the top-notch pizza here? Okay, call them. No. That's why I want to have this discussion, is to art of possible of what you can do. The code here is simple. All it does is takes the output of AI, it takes the output of prompt flow, converts it and puts it into CosmosDB. That's it. The power is in that prompt engineering. So it's such a very powerful thing.
So potentially you don't even use a keypad and mouse anymore. You just plug it into a computer.
Exactly. So you can open up and say, upload this that prompt stuff. You can tell it.
That's the most annoying thing about using the iPhone.
Yeah. So given this, if you had to say like, here's your source code repository, and then like you have an example, README and documentation, troubleshooting guide, and all this stuff, one set of files for like one API, and then given that you have a bunch of other APIs that are undocumented, you say, given the style of how we documented this one, go document all our other source codes.
Absolutely.
And then not only that, as we make updates and changes, as part of our definition of done, run this thing, I'll auto update the documentation.
You got it. Yes. The key word is the style, not the content. APIs contents are different. Contracts are different. It's the style. So it's going to detect code base. So you can use codex to figure out the style. For readmes and markdowns, you can figure out the style, whether there's how many headings are there, how many bulleted lists are there. Are they wrapped around that apostrophe for markdown to show code in there? Right? Leverage all that, build out that style, and use that in your prompt.
Yeah. And how long will it take until you have enough confidence that you can stand behind all the documentation? Like if it's auto responding to your Outlook, and if it sends a message that gets you in trouble.
Okay, I'm going to borrow my company's name. AI is not 100% accurate. Please do review it before you send it.
That's what my Tesla said. Yeah. Pay attention.
But the good point you raised, Dan, is that how do you know the one is generated is correct? Remember those metrics I said? Relevance, reliability, groundedness. That's where prompt flow comes into play. You run that. Accuracy. You run that. How you can, there's only so much you can tweak in chunking, because semantic chunking is one of the difficult things that I have done. And by the way, I'm not a data science person. I have no idea when they talk all this out. But I have dabbled in that. It's difficult. I don't even understand most of it. Semantic chunking is difficult. So please, if you're using AI, you will have to rely on a human audit before you send it. Straightforward capitalization, all this, no worries. But if you're going to alter the meaning itself, because it is going to generate, it's an augmented generator system. It is going to generate, it's going to predict based on what it knows. So there might be something. So that's why you have things like hallucination prevention, hijacking prevention, content safety filters, so that it doesn't fall back on its own to add additional words, because it does predict those words on its own. So, but yes, definitely do review the output before you send it. I mean, in Outlook, you guys have 365 in your Outlook Copilot. So it says draft an email. It doesn't say, let me send it for you. It says draft an email. It's still up to us to approve. It's the way. AI is still not there that we fully understand, fully kind of, because English, I came to know, is the third difficult language in the world. People think English is easy. It's not. It is so difficult. My wife would say that too. But yeah, so please review that. Yes.
Trying to figure out how to format my question, but
You can ask
in my world, basically let's say I'm a web developer, and the customer comes to me and says, we're going to get sued if our website is not compliant with all the standards for accessibility. Now, at the top level, it seems like you solved my problem. Yeah, I just have to have it rewrite the website using the standards. I guess my question is, how far away are we from being able to do something like that practically? Given that I'm working with a client who probably can't afford to do what I want to do for them right now, and to do all of this other stuff on top of it, that's not a good sale.
No. If you allow me, let me answer this in this way. It is possible now. This is not a solution that was done yesterday. This is there. I think the question we should ask is, when would it be practical for us to trust the output of the AI? Doesn't matter what AI rules or policies or summarizations or retrievals that you do with it, but the outcome of what the AI does, is it exactly what I had in mind, contextually, right? On top of that, does it encompass everything? Because human mind, right? Like, for example, I'm only like 16 years old, right? I have 16 years of knowledge, right? With a lot of connections and relations and their knowledge, my wife's knowledge, my in-laws' knowledge, my kids' knowledge, my friends' knowledge, the environment knowledge, the gestures knowledge. AI doesn't have those non-verbal knowledge yet. They need to be quantified.
I think none of us.
That's why they add that disclaimer.
Yeah, I think none of us are going to ask it to open the pod bay door.
It's up to it's going to come. It's going. A lot of huge improvements are happening in the way things are getting interpreted, things are being generated. But again, data is so much, right? It's not only we caught up with what December of last year or
Sure.
April of this year. And we don't even know from when it started. It's not from starting of time. The knowledge that imagine if my brain has got this much and yours of all this, all of us together, AI should be able to handle it. That's a lot of data.
Yes.
I think it's going to come, but the question I would ask is, how well will you trust it?
No, and that only comes from having experience with it.
Yeah.
And seeing
And how much information you
same
provide.
we have with people.
Yeah.
We trust them after we've seen the kinds of mistakes that they make
Exactly.
and what they do to recover from them.
Yep.
But it's
That's a good analogy. Thank you. It's like two people meeting for the first time, and whether they will say, "Yep, I promise you can take on my word. I'm going to $1,000 tomorrow."
am I going to ask her to marry me?
Doesn't go well.
No,
But
this is.
It's a matter of just trust.
As a relative outsider, but not an unknowledgeable outsider, this is fascinating stuff. And I wish I had it available to me now in a format that I could trust.
I mean, AI has been there for a long time. Clippy was also an AI.
Oh,
My favorite was Clippy.
Yeah,
You-
I was doing some work with neural networks and
There you go.
and rule-based AI
There you
in the early 80s.
Yeah.
And both of those things were hot topics several times between then and now.
The way I perceive it is trust is an issue with human beings. Human beings are generally very difficult to understand. It's a complex aspects of human beings. And all that has to be quantified for a machine to understand. That's why that sentiment and AI, Gen AI, all that is having difficulty to understand because we not only use language for our knowledge, we also use non-verbal stuff to interpret. And also you have the sixth sense of believing somebody. Sometimes you believe, sometimes you don't, which is highly difficult to quantify. And then we are the ones who are evaluating something that's helping us. It's kind of like a catch to it.
The old words from Ronald Reagan, trust, but verify.
Yeah.
I
And
don't know.
in that vein, can't you, you can also use AI to write your unit tests or whatever else. So like you could pit one AI against another. So like one AI builds it, another one.
Right. I also caution people, AI is only strong as the quality of the data it's found. If your data has my unit tests, you double check, triple check it.
Well, I think that, I think
But
the
if your
thing,
data is strong,
the thing that's scary about it is when they let people like me loose to use it. Or others of us, and some of us aren't quite as nice people as I am. So
that would be my answer to your question.
well, I hope I will be around to see it being used more and more well.
You will. It's coming up fast. Yes, sir.
So this is very cool. What's the cost model? So by which I would say, let's say if you're going to a company and saying, yes, run all your documents for this. I'm betting at some point they said, okay, but what's going to cost us per document to do that?
Correct. That's
So, and I know that the costs in this are changing fast, but pick any rubric you want. I'm just curious where this came out in the cost per page or cost per document. So when I think about applying this to a business, like how I apply it, they have a lot to do with how I can bound my costs and profit.
asking the difficult question on a live media.
Oh, I'm sorry. I'm sorry, I don't know, this was an easy question.
This is
Okay, sorry.
Frank, costing AI is different than costing any other resources that you have. Because everything else is based on compute, based on processor, based on memory, based on RAM, but AI is not any of it. It's based on consumption, it's based on tokens. What is tokens? I'm like, what? How much is one page of documents token? 2 pages. So to your point, it's a this one I haven't costed it out, but it would be average cost. I don't know what the average cost from your perspective it is. It should be, because there is no compute power in here. The intelligence is on the AI and the document, how much chunks you feed, how many rules you're running, and the responses that you collect. Right, that's where the chalk is. 1,000 tokens. So if you're running GPT-4 Turbo, that's about like 1/3 the cost of GPT-4 itself. And I generally stop there because after that, we have to sit and do the math, like take a document, run it through a token encoder to figure out how many tokens a document has on an average, and then do so. Sometimes 1,000 tokens doesn't make any sense. It's 1 million tokens because that's what the usage is. And then on top of that, you have to add concurrency and all that stuff. So in short, I don't know.
I mean, we're talking about cents a page, dollars a page, tenths of cents a page.
I don't know on top of my head.
Okay. Because that's the X factor of applicability.
Correct. I'll have to sit and figure out where your corpus
real
is.
fast with multipliers. I had a customer, we ported them from Azure SQL to Azure Storage for something. Their costs went up because we totally ignored the cost per transaction for Azure Storage. Because it's like, a quarter of a cent per million operations. That's nothing. Turns out for big enough values of millions, it's not nothing. And we engineered that solution.
Right.
So it's and that's a part of my question as I watch and see how this stuff responds.
Yes.
Particularly also I think about my experience using like GitHub Copilot has been pretty poor in that I can tell it's not fast enough. Like it's not able to get inside of my decision loop. So it's almost gonna be able to do stuff after I've given up and moved on. But I can also recognize the cost of making it fast enough.
Yeah.
Maybe unaffordable, where they'd have to charge me $1,000 a month for it. And so that's the interesting, and I think about the cost curve of running these models for the problems trying to solve at it. And the good news is that's something, at least in my career, has always been winnable, right? The costs have only gone one direction for these types of things. Although I say that, is AI like that? Because AI is unlike a lot of things. It doesn't improve linearly like we're used to with other algorithms, and maybe costs don't either. Maybe the costs go up exponentially as model complexity goes up. I really don't know.
The cost goes up based on your data that you ask and send it to process.
So size of
the prompt. And
yeah, okay.
Size of the prompt and the response. Like for example, I want to summarize an encyclopedia. That's a lot of tokens. And then on top of that, you can ask follow-up questions. That also adds up to your tokens. So that's what
it's got to keep because to do follow-up, it's got to keep the context of the tokens.
Yes, and that also needs to.
So a new follow-up is the cost of the new tokens plus all the original tokens.
Exactly.
Which makes sense because that's the size.
Yes. So that's why it is possible to calculate. I don't know top of your head what the cost of this will be. It depends on things like the number of users who are going to be using it. What's the document size generally on an average, and then we take that, run it through a token encoder to figure out how many tokens on average there are. And for 1,000 tokens for one user, it's going to cost, and add concurrency to it. So you're going to get.
There are also models that don't necessarily need the full GPT-4 model. You can get away with a much smaller model that's much cheaper to run. That'll give you a similar benefit if it's reading something.
That's why we want to find prompts so you can evaluate that.
For the capitalization thing, like a very low end LLM will be fine for that. That just needs to know what a noun is.
That's where the trade-off, right? Those three parameters, right? Cost, time, and risk, right? Yeah. You can't have all of them. If you're going to go with cost and you go with the lower model, maybe you look for the responsiveness and the relevance of the response that's coming back, because it will operate on lesser number of tokens and the knowledge base it has, right? Than the parameters. Like GPT-4 has got so many billion parameters it's operating on. So your response is going to be much richer. If you go to a lower model, my suggestion from a cost savings perspective is, if you really want to save on cost, go with a lower embedding model, or you do embedding compression. That is, you diminish dimensions. The GPT-4 ADA embedding model, for example, has got 1536 dimensions. You can shrink it down to some, so you're not creating that many level of parameters for you to calculate that. And then you have what is called semantic caching. So you don't have to hit Azure OpenAI. If 10 people, most of them will be asking frequent questions. So frequent questions, why are you asking OpenAI to generate it? Run it through a cache that's already accumulated the answer and check to see semantically the answers are there, generated from there, so that you're not touching your token. And then you also have a token rate. So there are multiple ways you can do cost reductions, but from cost perspective, we'll have to sit and work out of your document size, your concurrency users load.
There's a token, there's a process. I'd also say, well, please speak to a Microsoft licensing. Well, to that end, you can pre-buy tokens, you can get an enterprise agreement, you can negotiate reserved instances for tokens. Like you can get out, there are a lot of ways that you can get more efficiency in terms of what you pay.
But it's a good point. You
I felt like when the plumber's like, so we've got to replace the entire sewer line for your house, but don't worry, I've got a payment plan for that. You know?
It's, for people who have not done AI, it's something to have to worry about. Are the tokens, are the costs associated to the tokens? It's a completely different way of thinking, and it takes a learning curve to understand what exactly is a token. Because the token size for this solution may not be applicable. You can't just say generally, as you said, for SQL you can say it. You can. For this you can't. Just because this solution uses $1,000, the other won't. It entirely changes completely. It's a little bit of a pain there, the way it is wired up at the moment. But hopefully in the future they will reduce it and say, answer simple questions like, okay, for this, for 1 hour for 10 users, how much is it going to cost me? Simple.
We tried to make that tokenization model. I mean, we looked at kind of, do you want to rent time on GPUs like a CoreWeave or a Lambda Labs or a Paperspace, or do we want to build some intermediary model where based upon the number of characters and the number of words and paragraphs you send over, that determines what ultimately we charge you too. Because you can, I've seen CTOs and I've seen CIOs who are like, I'm not going to pay Microsoft for this. I'm going to go build my own GPU cluster. And then they start pricing out H100s and they price out InfiniBand and they price out all that stuff. And I mean, a GPU cluster will run you a little over $528 million just to build one. And that's 8 GPUs. And that is with 1,024 nodes, and each node has 8 GPUs in it too. And that's standard size for a lot of that. So if you want to pay 528 million and then the OpEx for doing that, or would you rather kind of look at the tokenization model where you're like, oh, I'm just going to pay for what I use here too?
I mean, I like the concept that the problem is, I haven't heard of a token is a quarter of a cent or $5. And so like, it's really hard to get an idea of then how I can apply the problem without, like, if I think about, my last role and what we were starting to do with ML, we came up with one solution that was brilliant, and we realized there's going to be literally $10 a transaction for us to run it. And it was like, okay, we're going to charge 20. Let's go back. And then we found we made some, I'm not going to say dumb mistakes, but some learning mistakes, and got it down to, I want to say 25 cents, and then ship that. But it was again born out of the like, yeah, that's a small number for that. Surely it won't be expensive. Hey, look at that bill kind of moment.
No.
And so like the economics of the business side of it.
It's always there. It's not only just the cost, it's also the ability to tweak the results of the AI. What if the AI results are not correct or not to the accuracy that we want? How do we go about it? Those are the big pain points that I've seen in every AI model. Because AI is getting to be more boxy as we go. A lot of stuff is out of the box. We don't even know what's happening inside. How do we tweak it? We have to tweak it, we got to pay for it. I'm not sure it works if you pay for it. So the fine-tuning aspect of it. So it's a little bit risky from that perspective. So at least from a tokenization cost, definitely would sit down and work out. It's not a technological challenge. It's more about the way you use the system, but from a consumption style, not for say a hardware resource style. It's a different way of thinking.
We've had to talk to some of the people like in our business unit. We're doing some of the stuff with OpenAI and Azure now. So the easiest way we've gotten them to understand how the pricing kind of works is that it's not quite per word, but you almost pay per word.
Yeah, 4 characters approximately.
Right.
4 characters is 1 token approx. But again, you don't put hyphenated words in there.
Right.
You don't accented words in there. It's just simple.
So I had a question more about some of the AI stuff. So let's say hypothetically you want to have like something like write a contract. Like each contract has different like standardization for like different states, different contract work, everything. I guess my question is like, how would the AI be able to essentially solve that? You have to create a template for you. Does it give this hallucination become much more prominent for those kind of aspects?
So if you have multiple types of contracts and you want to use the contract as template and have the AI generate the contract or rewrite something, so you won't hallucinate. You can control that through your prompt engineering. But what you can do is you can store those contracts and assign a tag to them. So when you're loading up the rules, right, you can say, give me all the contracts that pertains to this tag, and only those rules for those contracts will get pulled up, and you run it in parallel. And then you pick up another one for that different type. So it's how you tag your contracts as rules, and then you take that and give it to Azure OpenAI as part of the prompt.
Tag the contracts and the rules.
Yeah, it's another data source. If you want to say, I want to search for DP solutions, and I also want to search YouTube, but I want to make sure that I can filter them out. Right? So you put all documents related to DP solutions as a tag called DP solutions, and then all for YouTube's at YouTube, and then you can provide an interface where choose which one you want and choose both. So you can do multiple data sources and then pull them up appropriately, bundle them up in your prompt, and give it a prompt. OpenAI is like garbage in, garbage out. Yeah. It's stateless. It doesn't remember anything. You give it, you get it back. It's how you give it is where the skill lies, and what you give. Any other questions? If you're interested in the repo, please, this is a private repo, but I generally don't make money from it. If you want to share your GitHub handle, I will give it to you guys. You can take at it, play at it, everything. There's nothing in the all that stuff. You can go at it. Just share your GitHub handle, and I'll share my repo figure if you want it. Okay. And please reach out if you have any questions with AI. I love working with it. As far as search is concerned, there's a lot of search solutions out there. You name it, they have it. But I'm more interested in how you take that search and evolve with it, add more to it than not the search. And I've done a lot of search stuff. Please feel free to reach out with any questions. Cool. Thank you so much.
Well, we want to thank you for being part of tonight, and certainly thank you for being part of our first back in-person meetings, as well as our anniversary meeting. And it's just too good to be true. I think he's AI. You are real. Okay, just checking.
I used to, I renamed my word as KAIDAMB.
Yes, we'll sense that in a rule. We'll check it out. All right. So again, just want to thank everybody for coming out tonight, and I hope to keep seeing everybody. Again, we're going to go to more of a quarterly type style meeting, and dovetail with the Balto MSDN meeting schedule as well. So feel free, excuse me, to mix and match between the two. And again, thank you for DP Solutions for providing us the space. Really appreciate that. And it's very good, and there's plenty of it back there. So if you didn't get any, have some. It's really good. Where'd that come from?
Place around the corner, Italiano or a different spot?
No,
Philly's
Philly
best.
cheesesteak, like
Yeah.
it's 3 minutes.
Philly's best.
Yeah, for those who remember the CMAP years of past, we always had the Papa John's pizza. This is not Papa John's pizza. So definitely get some. With that, we're going to shift over to Sapwood, right?
Correct.
And it's like right across the street.
Corner. Yep, go to the light, take a left.
Okay, sorry.
Complex right there.
All right. So
And
that's
and Jeff said earlier that it's the best beer in Howard County, I think was the.
I will say it's definitely out there. Yeah, it's well. So I'm a certified beer judge. I'm a bit of a beer snob, but yes, it is my favorite place, and I think most beer judges in the area would agree that they've got fantastic beers.
okay. So that's good. So if you want to come out and join us, have a beer, or if you just want to join us and chat and talk about some of the other stuff, certainly welcome to do it, and we hope to see you all over there. But other than that, we'll say good night for tonight for CMAP meeting. Thank you all for being here. Thank you. Thank you.